Okay, welcome back to the Tech Motor channel, and today we're programming our robot. We're just toying with it a little bit and seeing what's the best way of doing it. There doesn't seem to be a good way of doing it. It all seems complicated. But basically I'm trying to take Python code from a PC and I'm trying to control this robot. So his head goes backwards and forwards, it goes up and down, his eyes light up. But I want to be able to call on it in Python code. Now in Python code, the way I'm doing it anyway, you could only send an on or an off to an Arduino, which is no good if you want a servo to move to a certain position and move back again. Certainly no good if you have 2 or 3 servos or lights and all the rest of it. So you need to write quite complex Arduino code, but then you need to call upon it from Python. So the way I'm doing it, I've got this control board here. And these gadgets on the right hand side are relays, and relays are just electronic switches. So I can turn these relays on or off using the control board. And then the idea is that that control board then, when the relay switches, that would be like me pressing a switch. So when I press a switch, the Arduino knows that that means move the neck to here, do this, do that. So just as an example, I've set up on my headboard a few switches. There's a few buttons here and here. Simple pull down resistor. So in its resting state, it's high. No, yes, in its resting state, it's low. And when I press this button, it takes it high. So that the code over here knows that when it's taken high, it's switched, and therefore it does what it's told to do. So I've programmed these 2 switches with 2 gestures. So one is a nod, and one is a shake of the head. So if we go ahead and press this button here, he shakes his head. If we press the other one, he nods. And so by doing that, I should be able to set up all of the relays to the Python code. So I can just say turn on this relay, turn on that relay, turn off this relay. And then I can connect those relays to the Arduinos, and the Arduino will be waiting for that relay to switch. And when that relay switches, it will run a sequence of code, whether that be a nod or a shake or turn the eyes on or off. So I can have quite complex Arduino code and call upon it with just an on or an off from the Python. And then Jarvis, that's written in Python, I'll be able to use the voice control and just say Jarvis, and he'll say yes sir. But when he says yes sir, I'll be able to call upon the relay that makes his head move to that gesture. Probably doesn't make any sense, but it does. It's just complicated. It's going to mean a lot of wires, but it does mean that I can call on the gestures in one line of code in Python once I've sorted it all out. So that's the next thing to do. Okay, so we come across a little bit of a technical hitch in that the Arduino is obviously looking for inputs. So you have inputs coming in, and then it's sending outputs to my servos and my lights. Now, an Arduino Uno, which is this small thing here, only has 13 digital inputs and outputs, of which a small number of them control servos, PWM ports. So that means that if I have, let's say, 2 servos for the neck and the lights, that's 3 of my I/O ports taken up, which means that I only have 10 ports left for gestures. So I can have move head left, move head right, move head up, move head down, nod, and so on. But that's as far as you get. And that's not going to be particularly lifelike. So I think we'd probably want, I don't know, 40 or 50 gestures that I can call upon in the Python code, and that's just not going to be good enough. So the answer is to move to Arduino Mega 2560s, which have a lot more I/O ports. It's a bit of a faff because I'm going to have to take these Unos out and reprogram everything. But it does open up a huge amount of gestures to me because I can have 3 boards in there, and the Mega 2560s have a lot of I/O ports. So that's what we're going to do next. Okay, so Amazon have just delivered. I've got these Mega 2560s. So I'm going to open these up and show you the difference. Okay, so you can see the difference between the Uno and the Mega 2560. All of these down here, that's effectively what you get on the Uno. So you get 0 to 13 of your digital inputs there. you still have your analog inputs down the side and your power and so on down here, but then you gain all of these ports here as well. So there's a lot more I/O ports for us to use. Okay, so just so you can see as a comparison, I have put in the Mega 2560, and this is the Uno. So you can see quite a lot smaller. So effectively that is the Uno, and then all of those at the bottom are extra I/O pins that we can use. So it's taken a little while to get it in because none of the holes matched, but let's get it wired in and see what happens. Okay, so I've got to put these two wires here for the power into these ports here, and the port numbers are written on the sides, but unfortunately I'm now too old to do that without glasses on. And I just wanted to point out that in the Iron Man films, Tony Stark wears glasses, but when he's wiring stuff that's really sort of, careful wiring, does he put his glasses on? No, he doesn't. So I have to put my glasses on to wire up this. Okay, so we're back to where we were yesterday when we realized that we needed a 2560. So we have the 2560 in place. That's all powered up. All the wires are going to it. And we've just assembled our two switches here, which symbolize the relays over here eventually. So I programmed the robot with two sequences, one which is center to left, and then he just stops. And if you press the other button, he goes left to center. There you go. So we're going to program in loads of different gestures, and then put each one of those to each different switch I/O on the board. So from 0 to God knows how many pins there on there, we'll have different gestures. So here we go. And we've done the same thing for the eyes. And then this is a sort of boot sequence for the eyes. So it fades in, flickers a bit, and then fades in again before turning off. Okay, so that's the basics. We've got center to left, left to center, center to right, right to center, center to up, up to center, center to down, down to center. We've also got a boot sequence where he kind of raises his head slower than he normally does. And then we've got a shutdown sequence where he raises, where he puts his head down slower than normal. We've got a boot sequence for the lights, so they kind of flicker on, and we'll put some sound behind that. And then we've got a simple sequence for just lights on and off, full brightness off. So that's the basics. We've then added in a nod sequence and a shake your head sequence. So now we're going to add in a few extras like thinking pose, conversational sequence. So you basically have a sequence of movements which look like I do now when I'm moving my head around as I'm talking. We'll have a sequence of maybe 1 second, then we'll have a sequence for 3 seconds, a sequence of 5 seconds, then we can call upon those in our Python code. And then once we're done with that, that'll be good for now. And as we start programming him, we might decide to have different gestures. So we might decide that we want him to look up and to the left, or we might want him to do something else. But we can create a lot of those scenarios by saying center to left, center to up, and then he'll look up and to the left. But for now, programming the basics, and then we'll program in our relays, and then we'll get our Python code up and running and get him talking, get the sound effects, get the lights and the movement all working together. Okay, so the next thing to do is to wire up. Let's get this so you can see it on the light. So the next thing to do is to wire up the Mega 2560 to the relay. So on the right hand side there, you can see all those wires coming out. They're the wires that go to the coils of the relays that switch the relays. So I need to bring those wires over to the Mega 2560. Now all of these go through a ULN 2003A, which is a Darlington driver IC. Basically that means that the output from the Arduino is bumped up. So it's given a little bit more power to switch the relay. Relay switches, that acts as a normal switch going into the Mega 2560 and so on. The difficulty is that the wires coming out of the relays are here. And then what I've got to do is I've got to take these wires, which have female to male connectors, connect them all up to the same colors, poke them through this hole here, and then plug them into the Arduino, which is going to take forever. Okay, so that's done. I've wired all of these together. So I've got white to white, yellow to yellow, and so on. Same on this side. So these are all the relays. And then the board that has the relays on it has its own power supply, because as I said, it needs to bump that power up a little bit from the IC on the Arduino. So these boards have their own power supply. So what we've got in the back of here is we've got our own power supply. So this is negative up here, and this is positive, and these are just you know, you poke the wire in, flick the switch, it's connected. So it's like a little junction box, but you can mess around with it and take it in and out fairly easily. Like the old-fashioned chock blocks, but just without the annoying Phillips screwdriver head. So I'm going to wire up the power on both boards, and then we're going to wire all of these IOs into the Arduino. Okay, so all that wiring is done, and then now we've got all of these wires coming through nice and neatly on this side. So that carnage on the back, the reason I've created that port on the back is so that you can't see the mess. So these wires will be neatly plugged into these ports on the Mega 2560. However, I need to do this in a certain way so that it makes sense later. So on the relays, I need to get the right colours in the right order. So for instance, 1, 2, 3, 4, 5, 6, 7, 8. And then on this side, 9, 10, 11, 12, 13. Otherwise, I will spend most of my life trying to work out what colour goes to which input and output. So that's the next thing to do, is make a list and then plug them all in the right sequence. Okay, so the next thing we need to do is we need to set up our relays. So each one of these blue boxes is a switch, and it's a single pole double throw 5-volt coil. So that means that there's 3 pins on each relay. So the Arduino switches when the pin goes high. So what we need to do is take a high or a plus 5 volts to every single one of those relays, and then from each one of those relays to the secondary Arduino. So we'll just run one positive wire to the board, and then we will run a jumper cable in between each relay. So every relay is hot, and then when the relay switches, it'll send a positive to the secondary relay. Okay, so that's most of the wiring done. To you, it's been 10 minutes probably. For me, it's been 2 nights solid of wiring, cutting wires, soldering, heat shrinking bits and pieces, but that's all the wiring done. So in the next video, we're going to jump onto Python. We're going to jump into our Jarvis code, and we're actually going to start putting instructions into the Jarvis code so that when I give it a voice command, it will respond in the usual way, but it'll actually start moving the robot and turning the lights of the eyes on and off and things like that. And that's the fun bit, because we get to put special effects in. So when the eyes light up, actually you can hear sort of things happening in the background, and it seems more real. So in the next video, we'll do that. But for this one, we'll call it a day. Thanks for joining. I'll see you next time.